Hello friends and welcome back to my channel. This video is going to be very important for those who find difficulty in finding the geometry, hybridization, shape and questions of that kind. This shortcut is going to change your way of solving questions and you're going to save a lot of time in exams like GE and NEET. You can literally do questions of finding hybridization, geometry, shape within seconds. I can guarantee that. If you follow whatever I say word by word, you can do these questions within seconds. So this is going to be a very interesting lesson for you. So let's get started with the lesson and let's just start to understand how we can do the things. So we'll start with understanding how things can be done. So let's begin. First thing first, let me tell you how it works. Yeah. So let's start with this. See, what you do is suppose you have to find the hybridization, shape, geometry, whatever you want to find for a species. These are the steps that you have to follow and mark these steps very seriously. The steps that we can follow to do that would be, so let's, yeah, would be, yes, let's get started now. Yeah. So the steps that we have to follow, steps to find hybridization, geometry, shape would be this. See, please follow whatever I say word by word. And I can guarantee that will not have any difficulty in doing questions. First, find the total valence electron that we have in a species. Find the total valence electron we have in a species. Okay. For example, you have CO2. So how many valence electrons are there? So I'm going to call it as TVE just to save some time. Yeah. The total valence electron can also be said as TVE. So please find the total valence electron. So that would be carbon atom is how many valence electrons? So carbon is 2, 4. So what's the valence electrons? Yes, absolutely right. It's 4. So it will be 4. And how many carbon atoms are there? 1. So 4 into 1. Plus, how many electrons are there in oxygen? So oxygen contains 2, 6. There are 6 valence electrons. So it will be 6 into 2, 12. So what will be the total? Yes, 4 plus 2, 6 into 2, 12, meaning 16. Now, there's one thing you must know. Take the valence electron of hydrogen as 7. Why? Because it's on the basis of octet assumption. So since we assume it to be octet, that's why hydrogen is taken as 7. This is something that you have to take just for this particular shortcut technique. Okay. Now, as we are done finding the total valence electron, always divide total valence electron by 8. Always. Okay. First step, divided by 8. You will get some quotient. Yeah. That quotient would be the whatever you get here, the number, right? That will be the number of bond pairs. See, look at the effectiveness of this shortcut. You can actually find how many bond pairs it forms. Okay. And now I'll get some remainder. Whatever remainder you get, just divide it by 2. Always. First by 8, then by 2. What do you get? You'll get some another number. This will give you the number of, yes, you guessed it right, number of lone pairs. That will give you number of lone pairs. So the top one, bond pairs. Bottom one, lone pair. Step number 3. So please write it down. You can take screenshot of this. Okay, very well. Let's go to the third step. The third step is add number of lone pair plus bond pair. Okay, just add them. If you add the number of bond pair and lone pair and you get some values, add them. So if you add it and you get some values like this, then this will tell you a lot about the answers. So just a second. Yes. Okay, cool. See, if you see that the number of bond pair plus lone pair comes out to be 2, because that's the minimum we'll get, then hybridization will be hybridization will be SP. And how to remember? 2 means what? 1s, 1p. So 1s, 1p, 1 plus 1, 2. And the shape, or I would say the structure will be linear. I need to remember this particular thing to begin with. Next, this is the first. Suppose if the sum of bond pair lone pair comes out to be 3, then the hybridization, can you guess it? If 2 was SP, 3 will be SP2. Excellent. And the geometry will be a trigonal planar. And how to remember that? Tri means 3, 3, 3. That's it. See, isn't it very simple? Okay, let's go to the next one. 4. Suppose the sum comes out to be 4, it will be SP3 and it will be tetrahedral. Tetra means tetra pack, tetra core. See, quad core, tetra. Tetra means 4. So see, sum is 4, so it is tetra. See, all of things are related to each other. Now, suppose you get it as 5. Suppose you get it as 5. Well, in that case, could you guess the hybridization? S is 1, P is 3, D will be 1. SP3D. And the shape will be trigonal. Yes, bipyramidal. Excellent. Trigonal bipyramidal. This will be the shape. Sixth one, it will be SP3D2. And this will be octahedral. How to remember? One more thing. How 5 is basically a trigonal bipyramidal. What is tri? 3. What is bi? 2. So 3 plus 2, 5. SP3D. See? 1, 3, 1. 1 plus 1, 2. 2 plus 3, 5. Tri is 3, bi is 2. So 3 plus 2, 5. All right. And the last one what we have is 7. And if you have 7, the hybridization will be, can you guess it? Very good. SP3D3. And it will be pentagonal bipyramidal. How to remember it? Is it really difficult? No. Pentagon means 5, right? Penta means 5 and bi means 2. So 5 plus 2, 7. Everything is related. So what are the steps? You need to first find the total valence electron, divided by 8 first. Then you get the quotient remainder divided by 2, then lone pair. First we'll get the bond pair, lone pair, add them up. And we can also call it as nothing but sigma bonds. So sum of bond pair and lone pair is nothing but the other way of saying number of sigma bonds also. You know, it could also be this. Using this, you can do any question that comes to your exam. See, it's a very powerful technique. So I want you guys to take the screenshot of this page as well. So please take the screenshot. Okay, very good. Now let's start with some problems. Let's start with some questions. Or let me give you some analysis, how it actually looks like. See, suppose whatever I told you, we'll give some examples of this. Suppose the number of bond pair lone pair comes out to be 2. So how does it look like? Linear. What do you mean by linear? See, A in the middle, B here, just a straight line, linear, like this, linear, like this pen, linear, see, linear. And linear means a straight line, that's it. And example could be CO2, BCl2. There are so many examples we can have. What's the bond angle? Please remember the bond angle. I'll show you some animations also, but for now, just remember it's 180. Straight line. What's the bond angle? See? 180. See? 180. Very good. Next. If it comes out with 3, what is the geometry called as? Excellent. Trigonal planar. Planar in a straight line, somewhat like this, like the pad you have. See? Plane. So triangle planar. See? And what's the angle? 120, 120, 120. Example, BCl3, AlCl3, ArBr3, all these things. BF3. Fourth will be tetrahedral. Excellent. And how does it look like? Somewhat like this. I'll show you, don't worry. Tetrahedral. Bond angle 109.5. Sometimes you might see, that write it as 109 degree, 28 minutes. Don't get scared of that. 28 minutes is same as saying half degrees. Why? Because 60 minute is 1 degree. So 28 is almost half. Yeah. Good. Next, fifth one. Suppose you have trigonal bipyramidal. Why the name is trigonal bipyramidal? I'll tell you in just give me 2 minutes. And these are the examples. Bond angle 90 and 180. PCl5. Then we can have PCl5 and then PCl4 minus. There's some other many examples. Next, 6. Octahedral. Why it is called as octahedral? Because when you join these ends, no, it looks like an octahedral. Hence it is called as octahedral. Example SF6. Yeah, all these things are there. Now, the seventh one is going to be pentagonal bipyramidal. Meaning, one example could be iodine in the middle, 2 bonds like this, 3 bonds like this, 1 up and 1 down. See, IF, F, F, F. Here also F, here also F, here also F. So it's like a pentagon here. See, right? And one pyramidal up, one pyramidal down. So pentagonal bipyramidal. Angles are 72 degree and 90 degree. 72 degrees and 90 degrees. Pentagonal bipyramidal. So that's how we can, represent it as a 7. Hybridization is going to be sp3d3. Okay. With this, we are now ready to learn one more thing before we do the questions. But before that, let me just tell you quickly the animations, how we can actually understand it. So I hope you can see the screen now. So let me explain how this can be, studied in details. Let's start. Okay, take a look. Suppose you have, this. This is how, linear molecule looks like. What do you see? See, straight line. See, straight line. Right? It has straight line. Next, see, this is a straight line. That's why it is called as linear, straight line. What is the bond angle? 180. Example, you just put CO2 here, you can just put carbon here, oxygen, oxygen, carbon, oxygen, oxygen, double bond. See, straight line, linear. This is called as linear. Why? Because if I see, it's a straight line, linear. Right? Okay. Next, third, 3 bonds. How does it look like? See, what do you understand here? See, 3 bonds, and they're all 120 degree apart from each other. See, if you understand this in the 3D plane, how does it look like? See, it looks like this. See, 120, 120, 120. Okay. So trigonal planar. Why is it called trigonal planar? Because it looks like someone has drawn a triangle. See, it looks like someone has drawn a triangle on a plane, on a piece of paper. Okay. Next one. Suppose I bring another bond. This is tetrahedral. See, how does it look like? It's a 3-dimensional shape where it's like a tripod stand of a camera. See, like suppose this is the camera and that's the tripod stand. These 3 bonds are in plane. These 3 bonds are in plane. One top. That's why it is tetrahedral. What's the bond angle? Not 90. It's 109.5. It's 3-dimensional. See, it is 3-dimensional. Okay, another one. Suppose you have 5. Pentagonal bipyramidal. Why it is called as pentagonal bipyramidal? Let's try to understand. See, if you join these centers, what do you see? You see, sorry, a triangular bipyramid. Why it is called triangular bipyramidal? See, it's a trigonal base on which I can draw 2 pyramids. See, pyramid on top and pyramid at the bottom. Let me explain how it's to be done. This is trigonal one on top and one bottom. See, pyramid 1, pyramid 2. Trigonal on a trigonal base, one pyramid on top, one pyramid at the bottom. It makes sense, right? See, hence the name is trigonal bipyramidal. Try to understand. These 3 bonds are in one plane. See, one bond is out, one bond is out. What are the bond angles we have? 2 types of bond angles. 120 in the diagonal plane, 90 top and bottom. Now they may also ask you this question, that how many 90-degree bonds are there and how many 120-degree bonds are there. So how many 90-degree bonds are there? See, first 90-degree, second 90-degree, third 90-degree, fourth, fifth, sixth. Six 90-degree bonds are there. See, then we have here also. So let's see, and these are 120-degree angles. So this is how we can find it. Next, if I add another bond to it, how does it look like? See, it looks like as if there is a planar square base on which there is a bond on top and this bond at bottom, octahedron. So four bonds are on one plane, one bond is up and one bond is down. It is called as octahedral. See, octahedral. Have a look, three-dimensional figure. And if I that's it. This is the end of how they look like. And I hope you got it. It was an informative session. Now we'll go to the next part. On there's a very special thing about pentagonal bipyramidal which you must know. After that, we can do questions. So let's begin. See, especially for pentagonal bipyramidal, I'm telling you a very, very important point. Only for trigonal bipyramidal, my bad. Only for trigonal bipyramidal, I'm telling you a very, very important thing. Please note. Only for trigonal bipyramidal, there are some rules that we must remember. This rule is called as Bend's rule. Bend's rule says that, see, for a trigonal bipyramidal geometry, A, the central atom is in the middle. Three atoms are in 120 degrees apart from each other, like this. See, 120 degrees. B, B, and B. And there is one up and one down. See? Now, and these angles are 90. Cool. So trigonal bipyramidal. These bonds are called as axial bonds. Okay. These bonds are called as axial bonds. And these bonds are called as equatorial bonds. Equatorial, axial. Okay. So where do we have more angles? Equatorials have more angle. How many? How much? 120. Whereas axial bonds have 90-degree angle only. See, only this 90-degree angle. That is the reason why the Bend rule plays a role here. What's that rule? The rule says more electronegative atoms, more electronegative atoms like fluorine, they always occupy axial position. If you have a fluorine, always put it on the axial position, always on axial position. And if you have lone pairs or double bond, multiple bond, triple bond, whatever you have. So if you have lone pair or multiple bond, put them on equatorial position. Put them on equatorial position. Okay, that is as simple as that's what Bend's rule mean. Now, if I keeping in everything in mind, we're almost there to start doing the questions. Cool. So let me tell you one more point, and then we'll start with the problems. Okay. So we'll start with the questions in some time now. One last thing. I hope this is clear. Yeah. So please take a screenshot of this one. Okay. Done. I hope it is finished. Now let's go to the next page. Okay. Next, the last thing about this. Difference between shape and structure. What is shape and what is structure or geometry? See, when they ask to find the molecular geometry or structure, they actually expect you to find the skeleton, how the real molecule looks like. So it is with lone pairs. Okay. So structure is studied with lone pairs, whereas shape is studied without lone pairs. This will be a very, very important thing to understand. Shape is studied without lone pairs, whereas structure is studied with lone pairs. Meaning ammonia. See, look at ammonia. So ammonia has how many bond pair and lone pair? 3 bond pairs and 1 lone pair. What's the total? Yes, the total is 4, right? As the total is 4, it should have tetrahedral geometry, right? It should have tetrahedral geometry. So the structure is tetrahedral. Structure is tetrahedral. But what is the shape? Shape is without lone pair. So tell me, if I erase this lone pair, what do we have at the end? See, we have, yes, excellent, the pyramid. So the shape is pyramidal. So shape and structure are different things. Structure is with lone pair, shape is without lone pair. That's it. Without lone pair, how does it look like? It looks like a tetrahedron. That is what you have to remember and keep in mind. And then I told you this bent rule. Please take a screenshot. Okay, very well. With this, we are now ready to solve n number of questions. Be it any question, we are ready and we can do any questions. So let's start. Let's do a few questions on this. So let's start with this. I want all of you to get your pen and paper ready. Okay, very well. Let's begin. First question. They're asking how many bond pair and lone pair do we have in XCF4? So pause the video, take a minute time, do it. So please pause the video. Okay, if you want to pause longer, you can pause it longer on your own. So what's the answer? Okay, let me first ask you what you have got the answer as. So what's the answer you guys have got? Okay. Okay, let's see. It could be A, B, C, D, anything, right? So let us see what is the real answer. Okay. So let's have a look what the real answer looks like. So let's begin. So the answer will be C, XCF4. So what should we do first? Yes, correct. Finding the valence electron. So total valence electron. How many valence electrons xenon has? Xenon belongs to a noble gas family, right? So valence electron will be 8. How many valence electron fluorine has? 7. 7 into 4, 32. 32 plus 8. 7 to 4 is 28. 28 plus 8 is 36. Now, as I got the valence electron, what should I do next? Excellent. Divided by 8. If we do so, we'll get 4 bond pairs, which is 32, and 2 lone pairs. So 4 bond pairs and 2 lone pair. So how many bond pairs are there? The bond pairs are how much? How many? 4. And lone pair 2. So they're asking lone pair and bond pair. So the answer is option number B. Excellent. So that is the right answer. So let's have a look what the answer is. Yes, of course, the answer is B. And this is how we approach it. So please write it down. Okay, let's go to the next question. Next question. Okay, they're asking on the basis of VSEPR theory, predict the shape of the molecules. How to do this question? So please pause the video, take your time, 2 minutes time, not more than that, and do it. So please pause the video. Okay, so let's solve it now. First question, SIF4, how to do it? They're asking the shape meaning without lone pairs. Very good. It's without lone pairs. So SIF4, how to find it? Find the total valence electrons. So how many valence electrons silicon has? Yes, 4. Fluorine has 7. 7 into 4, 28. 28 plus 4, 32. 32 divided by 8 first. What do you get? 4. 32, 0. 4 bond pairs? Sadly, 0 lone pairs. So 4 plus 0, 4. Tetrahedral. What's the shape of this? Tetrahedral. Why the shape is not different from structure? 0 lone pairs. No lone pairs, no difference in shape. This guy is tetrahedral. So first question's answer is tetrahedral. Okay, next question. NH2 minus, amide ion. So how to do it? Minus. So how to do this question? Very easy. Just find the total valence electron. So how many valence electron nitrogen has? You're absolutely right, 5. Hydrogen has how many? I know it has 1, but for this shortcut, we'll take it as excellent, 7. As I told you in the beginning of the chapter, topic today. 7 into 2 is 14. 14 minus means what? Electron is gained plus 1. What do you get? 5 plus 1 plus 14, which is 20. So with 20, If you divide it by 8 first, you get 2 bond pairs and 2 lone pairs. 2 bond pairs, 2 lone pairs. The sum is 2 plus 2, 4. So what is the geometry? Tetrahedral. But what is the shape? What's the shape? With 2 bond pairs and 2 lone pairs, how do we draw it? So we know tetrahedral has this kind of structure, right? So we have to place 2 lone pairs and 2 bond pairs. I have to put lone pairs somewhere here, right? And these are the hydrogen atoms. So how does it look like? Shape is always without lone pair, right? So without lone pair, how does it look like? Remove it. Without lone pair, it looks like someone has drawn a bent line. See? Just a bent line. So the shape will be bent or angular. It won't be tetrahedral because they're asking shape, and shape is always without lone pair. So please take this screenshot, and this is how we do this question. Next one. Third, NH4 plus. How to do it? Same. Total valence electron will be, see, nitrogen 5, hydrogen 7 into 4, 28, minus 1, which is 32. Divide 32 by 8, 4, 0. So 4 bond pairs, 0 lone pairs, right? So 4 plus 0, 4. What's the hybridization? Excellent, sp3. What's the shape? Tetrahedral. Is the shape different from structure? No, not really. So the answer is tetrahedral. That's how we do it. Last but not the least, C2H2. I gave this question on purpose because I need to tell you one thing. The shortcut only works when we have one central atom. Okay, since it has two central atoms, meaning there are two carbons, we can never have this shortcut useful. The shortcut is only applicable for this chapter, as in one center species. Now, what is the shape? Since it has sp hybridization, see, due to two sigma bond, this is again something we'll discuss in the upcoming lecture. Since we have two sigma bond on each carbon, hybridization is sp, hence it will be, yes, absolutely right, linear. So these are the shapes of this structure, these compounds given, and this is how we approached questions on finding structure and shape. So I hope you got it. So I please take the screenshot. Okay, now moving on to the next part. See, this is this answer. See, structure, V shapes, linear. Now, last question. This is a very, very interesting question. So, see, I have another video lined up where we'll be just doing questions from previous year JEE, NEET, CET exams. Okay, so we'll be doing questions only. This was just an idea on how to apply the concepts we've learned. So this is the last question for this lecture. After this, we will be having a separate session where we will be doing 30 questions, at least 30 questions in a very less amount of time. I'll show you how to do it in a quickest way possible in the next lecture. But for now, let's do it as the last question. The asking shape. What is shape? Yes, excellent, without lone pair. Now, ClF3. What to do first? Total valence electron. How to find total valence electron? 7 because of chlorine, 7 to 3 because of fluorine. What's the answer? 28. What to do? Divide 28 by 8 first. How many? How can we divide this? 3 times. 24, 4. Now remainder should be divided by, excellent, 2. So 3 plus 2, 5. 3 bond pairs, 2 lone pairs. What in my 3 plus 2? 3 plus 2 is 5. 5 meaning trigonal bipyramidal. Tri by 3, 2. Chlorine in the center, 1 bond, 2 bond, 3 bond, 4 bond, 5 bond. Now, where should I put lone pairs? I should put lone pairs as many they are onto 120-degree angles. What are the 120 angles we have? 120 angles are this one, this one, this one. So I can put two lone pairs wherever I want. Here, here, or here. Where will I put them? I will put them here because it will make them look symmetrical, symmetrical. And where should I put the remaining fluorine atoms? One here, one here, one here. Now you tell me, without lone, if I erase the lone pair, suppose I erase the lone pair, how does it look like? See, T. Very good. It looks like T. See, T. You get it, right? I mean, just bring it up. T. The answer is T-shaped, right? This is how we approach it. So shape is always seen without the lone pairs. And this is how you can do any question on shape, structure, hybridization, anything. For example, if for the same question, they asked you hybridization, how to do it? 3 plus 2, 5. Hybridization will be S, 1, P, 3. So 3 plus 1, 4. 4 plus 1, 5. So SP3D. SP3 hybridization. Simple. Within seconds, you can do it. So I hope the example that we've done was clear to you and you have enjoyed on, and you've learned a lot new things today. And from this, using this shortcut, you can do questions within seconds now. So if you really found this video useful, please share it with friends, and subscribe this channel and leave comments if you have any doubts, any other further doubts about this topic or any topic that you want me to discuss in this easy manner. So with this, we'll sign off now. Thank you so much for watching.